Because the array class provides so few instance members that you're likely to use very often, it's easiest to summarize the methods in a table. I've got that here. So clone creates a shallow copy of an array. Copy2 copies all the elements of the current one-dimensional array to another array. GetLength gets a 32-bit integer that represents the number of elements in a particular dimension. GetLowerBound gets the lower bound of the specified dimension. GetUpperBound gets the upper bound. And then initialize is a little bit cool. It initializes every element of the value type array by calling the default constructor of the value type. So it's a great way to initialize or reinitialize an array back to 0 or false or empty strings or whatever. And then, even though the system.array class provides a number of properties, there's really only two that you'll probably use fairly frequently. Rank property returns the number of dimensions an array has, and the length property returns the total number of elements. Okay, so the instance members really are rather kind of dull, although they are useful when you need them, certainly. Way better than trying to write some code to extract that kind of information. But it's the static members that perform some useful tricks, and that's what I'm going to be covering now. Let's talk about sorting the data that's in an array. Most likely, if you have data stored in an array, you'll want the data sorted at some point. Support for sorting arrays is built deeply into the .NET framework, but not all arrays are equal in this regard. If your array contains a single dimension of data of a single built-in type from the .NET framework, you can normally just call array.sort, call the sort method, as I show in this example here. The example demonstrates sorting the items in ascending order and then calling the array.reverse method to display the items in descending order. Okay, so I create this array of items, just a bunch of strings, names, and then I use the printAll method to print out the unsorted list. And then I'm going to sort the items, so I'm just calling array.sort. That puts them in alphabetical order because they're strings, and then I print them all out again. And then I call the reverse method, which reverses the order, as you might imagine from the method name, and then I print out all of the items again. Now, what's kind of interesting about this is that each time I call this sort method and reverse method, it's a static member of the array object, so I'm calling it on the array object itself. As you can see, this is the system.array. And it's actually changing the array that I'm passing to it. Instead of returning a new array in the specified order. I just want to make sure I point that out because static methods in the .NET framework don't always work that way. Oftentimes you'll need to, not so much with arrays, but with other methods that are static methods that you call against an object in memory, often will leave the original object untouched and return a new object, the result of that operation. So just be aware that that kind of varies within the .NET framework. All right, I'll run this code. And the simple sort, so E. And there you can see my unsorted list, Mary, Andy, Ken, Robert. Sorted list, it's in alphabetical order. And the reversed list is in reverse alphabetical order. So, pretty easy to sort simple built-in data types. The .NET runtime is able to sort any single dimension array of simple value or reference types for a very specific reason. In order to be able to do its work, the array.sort method calls the compareTo method of pairs of objects that it's sorting and can arrange the objects in the correct order. In order for the sort method to be able to sort an array, the items in the array must all be of the same type, and the type must provide a compareTo method. Now, before the array.sort method even attempts to perform its sort, it checks to ensure that the type it contains provides a compareTo method. How does it perform that check? Well, that's easy. it only sorts arrays of objects that implement the iComparable interface. If the type it's attempting to sort doesn't implement that interface, or if the array contains elements of multiple types, which would be declared as an array containing object values, it simply fails at runtime, raising an invalid operation exception. So now we're really starting to get into the depths of how sorting works. Here's an example that demonstrates this behavior. In this case, the code attempts to sort an array of writer objects. But because the writer class doesn't implement iComparable, notice that it doesn't implement any interfaces whatsoever, this code is going to fail. Okay, so the way it works, I'm instantiating a writers array. I'm going to have 4 writers in it. I'm going to initialize each of the elements to a new writer object. And then within a try block, so I can catch exceptions, I attempt to call the array.sort on writers. And the code is going to fail here because writers doesn't implement iComparable, and so it doesn't have a compare_to method. But otherwise, if it did succeed, I was going to print all of the writers. All right, so if I execute this code, I'll select F for invalid sort, and we get the exception, and this message prints. Sort failed to compare 2 elements in the array. All right, so to solve that problem, the sample project includes another class called Writer Sortable. And this does implement iComparable. Okay, so that meets the requirement. So now objects of this type I can sort when they're in an array. But in order to implement that interface, I need to implement the compare_to. And so what this is doing is this receives an object that is going to be compared to the current object, the code in which this object, the object instance in which this code is executing. And so because it has to receive an object, I need to convert it or cast it to a write sortable object. That's saved in other writer. And then I can compare this instance using the this keyword, call the compare_to of the name field, which is a string. And so strings have compare_to methods as well because they implement iComparable. And I compare it to the other writer's name. Because the way I'm defining sorting for writers is alphabetical order by author name. Okay, another thing about writer sortable is that it inherits from writer, so it gets all of the properties and method of the writer class. So all I needed to do was be able to implement this compare_to. And in this case, this is a variation of a constructor. What this is doing is that it is saying that if I construct writer sortable and pass in a name and a home state, then I'm going to call the base class's non-default constructor. So that's this constructor right there. So a little bit of new syntax, and it's fairly efficient for when you need to call the base constructor. Now, the way compare_to works is that it's going to return -1 if the current object is less than the compared value. And what less than means is going to depend on the data type. Strings are going to be in alphabetical order by culture. Numbers are going to be in numeric value, and so forth. And then return 0 if they have the same value, and +1 if the compared value is greater than the current object. Okay, and so it's really nice that the string object has a compare_to, so I can just use that, and that returns the correct value, and I just directly return whatever the return value of that comparison is. And that becomes the value that's returned by the compare_to of my writer sortable object. Okay, so here's some code that exercises that. So this is pretty much identical to the previous example, except I'm using the writer sortable, newing up objects with the same people and home states, trying this, sorting it, and this time it should display all of the writers. Select G, and there you can see Andy's from Florida, Don's from Alaska, and so forth. And they're sorted by name. So notice I created them out of order, and they're now sorted because this line of code successfully executed, because this is now an array of objects that implement iComparable and therefore have a compare to method.